Okay, this is going to be part 1 of a multi-part video series reviewing the following topics. This first slide is some of the formulas you'll have on your formula chart, and I'm going to show you another slide here in a second with the back. This is just in case you don't have one as you're trying to work some of these problems. You can come back or write some of these down on the certain problems that you need. Here's the back side of the formula chart. Alright, so the first problem we're going to work says that Jenny made a cylindrical clay vase for her art project. The vase has a volume of 339 cubic inches and a diameter of 6 inches, which is closest to the height of the vase. Okay, so we know it's a cylinder, so the first thing I would recommend doing is drawing a cylinder. I think it's always helpful to have a picture if you don't have to draw one. If you're not that visual of a person, that's fine, you don't have to. Also, we're talking about volume here that's given. So the formula for volume of a cylinder is pi r squared h. Now if you looked on the formula chart, it says capital B times h. What you need to remember is that capital B is area of the base, and our base is a circle, so area of a circle is pi r squared. So I simply replaced the capital B with pi r squared. Now you're given some information. The diameter is 6 inches. The diameter, remember, is all the way across the circle. In the formula, they call for radius, so you remember you have to take half of that to plug into your formula. So volume, we'll plug in 339. And for radius, we'll plug in a 3. And we're solving for the height. That's the missing part that they want to know. All of these parts on the right side of your equation are being multiplied. I'm going to go ahead and simplify this a little. I'm going to go ahead and square my 3, and that's 9. So I'm going to have 9 pi times h. And like I said, these are all being multiplied, so to move something to the other side, you do the opposite operation, which is to divide. So I'm going to go ahead and divide by 9 pi. You can divide by 1 at a time. You can divide by 9, get an answer, and then divide by pi and get an answer, or you can do it all at once. Either way is fine, as long as if you're doing it all at once, when you type this into your calculator, you put this in parentheses. Otherwise, it will just say divided by 9, and then the calculator will multiply by the pi instead of dividing. So if you are doing it all at once, don't forget parentheses. Okay, and when you enter that in, you get a grand total of approximately 11.99 inches for the height of our cylinder. Okay, here's another cylinder. Pictures given this time. They want you to write an equation that best represents the volume of this cylinder in terms of pi. Remember, in terms of pi just means leave pi in your answer. Okay, so now we're not even solving, we're just writing a formula. So we'll start with what the formula chart gives us. Okay, and now we're going to replace B with what we did on the last problem. Area of the base, which is a circle, would be pi r squared. Now we look at what our particular vase has here. Well, the radius they just call r, so we're not going to have to change the r. But our height here, instead of calling it h, they want us to call it 4r. So I'm going to replace h with 4r. So now I have pi r squared times 4r. But I don't want to stop there because now I have common variables that I want to go ahead and simplify. So everything's being multiplied. Pi times r squared times 4 times r. Okay, so everything's being multiplied. So my r's, when you multiply these, this is just to the first power, and when you multiply exponents, really you are just adding the exponents. So this becomes r cubed. So I end up with volume equals, and I'm going to go ahead and put my numeral value in front. So 4 pi, and then r squared times r to the first power is r cubed. And now there is no simplifying to do from there. That's what they wanted. Number 3 is a triangular prism, and they want to know the volume. All of the dimensions are given here. Remember, a triangular prism, a prism means it has two bases, and it's named based on the bases. So the bases are the triangles. This one happens to be sitting on the triangle, so it's more obvious, but a lot of times it may be sitting on the rectangular face, and y'all get confused. Remember, if it says it's triangular prism, triangle is the base. So here, if this is 10 across, this would also be 10 across the back, okay, because these triangles on top and bottom are going to be congruent. So the first thing you need is volume for a prism, which is capital B times H, area of the base. So we have to come off to the side to find area of the base, which for a triangle is 1/2 little b h, or little b h divided by 2, if you prefer that. Now remember, this is the base and height of the triangle. We're only talking about the triangle now. So of this triangle, the base and the height are the two sides that meet at this 90-degree angle. So the 6 and the 8. So we have 1/2 times 6 times 8, and that gives you 24. So the capital B is 24. The height that goes in the volume formula is the height of the solid, of the actual prism. That is the distance from base to base. So from one triangle to the other is your height, and that is 8. 24 times 8 gives you 192, and our units were measured in inches, so volume would be inches cubed. Another cylinder. This one's a fish tank with a diameter of 8 inches, a height of 14 inches. He placed some rocks that took up 50 cubic inches at the bottom of the tank and then filled the tank with water 2 inches from the top, which is the best strategy for determining the volume of water that the fish has for swimming. So we're talking about volume. I'm going to go ahead and write the formula again. Pi r squared h. Now, there's a few things. We are not going all the way to the top. We're talking about the water, and he filled the water 2 inches from the top. So this is 2 inches. So that means we're not going to use this 14. We're going to take away 2. So obviously for height here, 14 minus 2. You could say 12, but if you look at your answer choices, none of them have 12, but 3 of them have 14 minus 2 in them. So I'm going to go ahead and mark out A because it does not. Okay. Now also D, it has 14 minus 2, but it has it squared. It has it in the place of R. Okay, this is the height. So you can mark that one out because it's plugged into the wrong number. So then you look at your diameter that's given as 8. That means the radius is 4. So for my radius, I will plug in a 4. And then of course I still have pi. So now all you have to account for is the rocks at the bottom. This will give you the total volume of water if you were to fill this all up, okay? And that would be in cubic inches because it's volume. But they've already used up 50 cubic inches with rocks. So then you have to remember to take that away. So minus 50 once you get the initial total volume. So if you look, the only thing different in B and C is the 8 versus the 4, so you had to remember to take half of your diameter to get your radius. So that one would be C. Alright, this one is a cylinder, and it says that you have this solid sliced by a plane as shown. What type of section does the plane make with the solid? What that simply means is, if this is like a blade or a piece of paper, it's just something cutting through this solid, and it's cutting at a right angle. If you were to open this shape up, what shape would you see on the surface? Okay, and for a cylinder, that would be a rectangle. Okay, so this is just kind of one of those visual, if I opened it up, what would I see? And sometimes the plane may cut across this way, and if the plane cut across this way and you opened it up, you would see a circle. So you have to make sure you're paying attention to which way it's being sliced and how you would have to open it up. Hey, this is another visual. These are really hard for some people, and some people they come very easily. It's really hard to explain and teach. It's kind of just whether three-dimensional figures, whether you have that, you have to be able to see what would be on the back side even though it's not shown. So for this one, they want to know what is not, and that's a key word. A lot of y'all are going to mess up just because you do what is. Okay, so what is not a top, front, or side view, and this is the side they're asking from. So if I look at the side, I know it's going to be long across the bottom, same length across the middle, and then a shorter length across the top. So it should be long, long, so equal lengths, and then shorter on the top. So do we see that anywhere? And I see it here. So long, long, and shorter across the top. So this would be a side view. So that could be, so that's not our answer choice. From the front, it's long across the bottom. It's just in the center, okay, nothing on the left or the right. And then on the top, also just across the center, nothing on the left, nothing on the top. So long, and then short in the middle, short in the middle. And I see that here, and it has that break because this is two separate squares. So this would be the front view. Now the top would be looking down, like if you're in an airplane and you're looking straight down on this. You would see this long portion on the right, okay, and then in the middle on top you would see a square, two smaller rectangles, and then on the left another large section just like the one on the right. Okay, so from up top that's what you would see, and that is A. So the one that is not would be C. They tell you that this one is made with 9 identical cubes. Okay, so 9 identical cubes, and that this is the front view. Okay, so we're looking at it head on at the front. Which of the following could not represent the right side view of the structure? Okay, so I'll go ahead and tell you, for those of you who have tried this, the answer is A. Okay, and I'll try to do my best to explain why that is, but again, sometimes it's just hard for people to see these. So I'm going to start back here on D. Okay, so if we look at this as the right side, so if I were to take this and turn it so that I'm looking at the right, I know that one of the levels has to go up 3 units because I'm seeing it 3 units high, and this shows that the back is up 3 units. Okay, and they're saying that the middle and the front are only up 1 unit. Okay, that's fine. And then the front shows that it goes at least 3 across, and that the left and the middle go, one of them has to go, it's either the front, middle, or back, goes up at least 2 blocks. So this saying that these only go up 1 mean that on behind this is the right side view, one of these behind this 3 level would both go up 2. So if I were to count that, over here was up 2, and back here was up 2, and then this is 3, and then there's at least these 2 in front. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is possible that it could be made with 9 blocks. So that's a possibility. Same thing with C. Same thing for B. It's a possibility. I don't have time to go through explaining all of these. But A, the reason that it's not a possibility, because for it to be 3 high in the middle and the back row, okay, that means that's all on the right side, because that's all we see 3 high is on the right. Okay, so you would have 1, 2, 3, 4, 5, 6, and then we know that the left and the middle have to have at least 2 in one of the rows because it's too high. So if we said that was 6, and they're saying there's at least 1 in the front row, that's 7, and then you have to have at least 8, 9, 10, 11. You'd have to have more than 9 blocks. This would take more than 9 blocks to create this, so there's no way this could be created with just 9.